Alrighty. See, now I'm recording. So you've got this car and constant deceleration. What does deceleration mean again? Yes. It doesn't necessarily mean negative direction. It means opposite velocity. Good job, some people. Well, there were such a variety of answers there. All right. So they're asking about distance and stopping. What does it mean when you stop?
Velocity is zero.
Velocity is zero. Okay, good. So those are the type of things I want to put here in my written line. All right. Different color. So the acceleration must be in the opposite direction as the velocity. When you stop, your velocity is zero. The more your velocity needs to change, the longer, the more displacement it will take. Make sense? Where I'm going with this? My thoughts? All right. So now I'm down here, and I'm looking at the question: W driving speed, does the distance required to come to a stop increase or decrease? Stop, increase by a factor of 2 or a factor of 4? I'm not sure yet. So I think I'll go on to the other parts and figure out these two stopping distances, and then go back to answer that one. Remember, just because they're in that order doesn't mean you have to add them, answer them in that order. All right? So, and I know I've got a deceleration of constant 3.5 meters per second squared. So, back here, I need a handy-dandy equation that relates velocity and acceleration and displacement. And that handy-dandy one is this one down here in this little corner. And that actually is the only equation I'm going to need for this. So if I do it for part A, which was mine was 18 meters per second, right, to start with. Now, do we want to say the car is moving, when it's moving, is it moving in the positive or negative direction? Positive direction. Is that okay with everybody? Yeah? That means the acceleration must be in the negative direction, right? Because they have to be opposite each other. So I know my final velocity, that's 0. My initial velocity for this one is positive 18 meters per second. I square that. That will be the most common mistake mathematically is to forget the square term. Most people will know what 0 squared is.
0.
Yeah.
That's a little too long.
And this, my acceleration has to be 0. Has to be negative. And then I'm looking for my displacement. And then the second part is just, what was it, 36? Rather than 18. And right away I looked at that and said, oh, wait a minute, 36 is twice 18. Oh, I square that, so that must be 4 times as much. So. And that's why in driver's ed, faster you go, the longer, more distance you have to get to stop in front of you. It's not a, oh, I doubled my speed, I doubled the distance. Double my speed, I quadrupled the distance. So. All right, so on to number 8. Two motorcycles start along a straight road heading north. So they've already established that north is positive. That 15 meters and moves at a constant speed. Oh, that must be the red line, because the red line has a constant slope. So I know that that's moving at a constant speed. 2 starts with x equals 0. It was a constant acceleration. Yep, the blue line is curved. Motorcycle 2 passes motorcycle 1 at a time of 10 seconds. Right? That's when they pass. To pass, you have to be at the same place, same time. Do you have to be going the same speed to pass somebody? No, just same place, same time. Oh yeah, and there's that first question. We don't even need to do anything with that. So here, so part B, we're gonna include that in our thing. Alright, so I think I have an idea of what I'm gonna do for my Y here. I'm gonna say, let's see. For the cycles to pass, they must be at the same location at the same time. Cycle 2 is going to be moving faster than cycle 1 when they pass, since the slope of its position graph is greater. The greater the acceleration, the less displacement for them to meet, and the less, and the pass, and less time. That's pretty good. I wouldn't say it's my best of the day, but try it. So, let's go back here and look at our data. We know it starts 0 and now it starts at 50, and we know the slope of the red line, right? So I'm looking at it, I'm going, ooh, the red line's easier to find out, like, where it's going to be after 10 seconds. Because it's a straight line. That just tells me, oh, math is easier, right? So I think I'm going to approach this, I already answered part A, really, in my diatribe. Oh, I should have probably put that in here. Maybe I'll just put a little note. Note. Listen to discussion for good points for a while. That'll work. So I'm going to use the constant motorcycle 1 to find out their location, and then I'll find out some stuff about motorcycle too. Okay? So let's see, I need some equations here. No, I don't think I need that. It's moving at a constant rate. So I can use a lot of people's favorite equation. Because it's moving at a constant rate, I can use this one. And so I'm going to figure out where it is. So I know, let's see, it tells me, I don't know where it ends up. We'll call that D. It told me it started at 50 meters. It's moving positively because I have that positive slope at 6.5 meters per second. And it does that for 10 seconds. So I get D and it'll be in meters. Right? Love it when we get a refresher of Unit 1. Makes life better. So then it wants to know, okay, well that's the same spot that the accelerating one gets to, but if the accelerating one's motion isn't described by any of these equations, it's described by these equations down here. So taking that, basically that same equation, just with the accelerated part added in, this is what describes the motion of that second motorcycle. So now we know where it ends up, right? Because we know this D is that D. Where did it start? At 0. This one started at 0. Its velocity initial, I think it started from rest, didn't it say? It moved for 10 seconds. Now it was speeding up, so is the acceleration in the direction of the velocity or opposite the velocity? In the direction of the velocity. So I'm expecting a positive value. Great. And then 10 seconds squared. Can anyone guess the most common math mistake here? Squared. We're getting that squared. Some people get in the habit of, as soon as they write down a squared thing, that's the first mathematical thing they do. Rather than 10 seconds squared, they write down 100 seconds squared. 100 units per second squared. So now this just solves for the value of D, which is from the previous one. And then the last part, they want to know how fast it's moving. So I'm going to go back here to my equation sheet. I'm going to say, well, now I need to use this one here. Oops. And in this one, as we said before, it starts from rest. I'm going to use that A value that I found, and then I know, of course, back to my 10 seconds. And that will do that one, right? All right, so on to number 9. Seagull drops a shell from a height of 13 meters. How fast is the shell moving when it hits the rocks? I love that it's just dropping a shell. I wonder if they worried that people would be offended if it was dropping actually, if they said dropping a clam. Because, oh, it's a living creature. I wouldn't be, but I bet some editor said, better have you just drop the clam, shell.
That's a living creature.
So, yeah. So nothing was injured in the making of this question. Alright, so how fast is it moving when it hits the rock? What color should we go with? Red?
Pink.
I haven't done green today. Let's go green. I've done orange a bunch. The shell is in free fall, thus centering downwards due to the net force on it being its weight. The further it falls, the faster it will be going at the bottom. Yay! Make sense? So, we want to know how fast it's going after it falls for 13 meters, right? So, I'm going to grab this one. And which direction you want to call positive, up or down? Down? That's a good choice. Down is a really good choice to call it. Because if it's down, then all my numbers are positive. Think about it. Which way is it accelerating? Down. Which way is it moving at the end? Down. So, great choice. Down is positive. So the V final is what we're looking for. If it's dropped, what's the initial velocity? 0. That could be in your Y. That's a great point. Put it in there and go, and then the person who's reading it goes, oh man, they know their stuff. And then 2, since it's in free fall, 9.81 meters per second. Because remember, down is positive, so I use positive there. And then the displacement is going to be positive 13 meters for me. If we picked down negative, we would have had a negative 9.81 and a negative 13 and gotten a positive. Yeah, it's
No.
What is going on?
It's okay.
What's
happening?
Does it need to be calibrated?
no, it does not need to be calibrated.
That's a classic
I don't
Freeman
know.
operation.